Hi, this video is going to be a quick introduction to CDER, which is a particle physics event display inspired by the Atlas experiment. The goal of CDER is to show high-level objects reconstructed in the detector, such as taus, electrons, jets, muons, in such a way that you can understand their configuration in 3D space for different physics processes. CDER at the moment do not work in 64-bit, it only works in 32 bits, so I need to set a 32-bit version of root for it to work. And of course CDER depends on root because it reads root files, which are commonly used in particle physics. So I launched CDER with Python-32, and there it is. So you have an animation of some calorimeters being constructed. You have a blue one to represent an electromagnetic calorimeter and an orange one to represent an hadronic calorimeter. These two pieces of detector are there only for aesthetics. They show you where the beamline is so you can understand your own orientation in 3D space. If you see down there that you have press H for help, and if I do this, then I get a list of the different controls that are available in CDER. Let's start with event navigation. So if I press the right key, then I summon the first event in the sample. And if I press right again, then I summon the next event, and then the next, and the next. And I can press the left key to go back in the events. And if I want, I can press the up and down key to summon a random event in the sample that I can currently browse. The total number of events that can currently be browsed are displayed at the bottom of the terminal right here, which is 4,407 in this case. So at the moment the calorimeter is rotating on the screen, and I can stop that rotation by pressing D, like this. And if I want, I can click and drag to select my own point of view. And I can also scroll up and down to zoom in and out on the event. And if I want, I can also start the rotation again by pressing D. And of course, when the rotation is ongoing, you can still manipulate your point of view. There are two predefined points of view. If I press A, I get a transverse view. And if I press S, then I get a longitudinal view. And of course, when I press either one of these keys, the rotation stops. Okay, so let's look at the different types of events that we have in here. You have this red-pink line that is shooting out of the calorimeter. This one is a muon. You have this yellow line down there, which is a tau. And then you have two collections of orange and white lines, which are jets. And you have this green fuzzy line, which is a transverse missing energy. All these five objects have their kinematics printed in a table in the terminal right here. And the colors are made to correspond to what is displayed in CDER. If I switch to the previous events, then we have a couple of other types of objects. Sorry, the next event. You have this blue line over here, which is an electron, and you have a jet, which has a teal aura, which is a B-tag jet. Alright, just a word about taus and jets in CDER. You can see that the tau here has two lines, so it has a yellow line and a white line to represent a charged pion, the yellow line, and a neutral pion, the white line. This is a one prong plus pi0 decay, and this decay is not real. It is simulated on the fly when you summon the event, just to give the appearance of a tau. And the same goes for the jets, like the particles that you see, the orange line representing charged particles and the white representing neutral particles. They're not real either. They're just simulated on the fly to simulate the appearance of a jet. So for example, if I go one event forward and then I go back, then I face a different tau decay. This time we have two neutral particles in the tau decay. Alright, something else you can do in CDER, if you want to look at one specific type of event, you can apply a cut. So for example, in this case, I want to look at events which has a large number of jets, so I'm going to select num-jets larger than 4. And the syntax to apply these cuts is the same as you would use in root on copy tree, so you just cut on existing branches in the root file. So if I press enter, then CDER automatically selects a random event which passes the selection. In the table you can see that I have 13 events that passes this selection, and yeah, so I can navigate through them and look at them. There you go. Another piece of information like this, the other thing I haven't really talked about so far is that other table here in the terminal, which is called extra information. You can in CDER customize your own reader to read your own root files, and when doing so, you can define a function to read some extra information in your tree. So of course the only information displayed in CDER in the 3D display is about the kinematics of the objects. But if you want to look at the values of different variables that you calculate from these objects, then you can print them in the extra information table. You can have a lot more information on how to do this on the wiki of the CDER project. If you go on bitbucket.org/emitc2h/CDER, then you have the project page where you can download the source and look at the wiki. And that's it. Enjoy!